Hi, welcome to my channel. In previous videos, we discussed about the linear SVM classification, linear support vector machine classification, and soft margin soft margin classification, and also we discussed about the nonlinear nonlinear support vector machine classification. Okay, that is SVM can work on the support vector machine will work on the non-linear data set and also non-linear data set. We already discussed the linear data set and the non-linear data set. Now in this video I'm going to explain about the polynomial kernel. Okay, this is one of the greatest technique to work on the any type of data set. It may be linear data set or it may be non-linear data set. This concept is called as a polynomial kernel. So kernel is a very important technique to classify the given data into two classes or multi-class classifications. Okay. Now here the polynomial kernel. So here we are going to add a polynomial features to our data set is simple to implement and can work great with all sorts of machine learning algorithm. So with the help of feature adding, okay, you can work out any type of machine learning algorithms. Now at a low polynomial degree, so the degrees are in the form of the polynomial degree. It may be low degree or high degree. Okay, low degree or high degree. There are two types of degrees are there. One is the low degrees and the high degrees. At low polynomial degrees, this method cannot deal with a very complex data set. So that means if the polynomial degree is very low, then this model is not work with a very complex data set. And with a high polynomial degree, it creates a huge number of features. And it making the model is going to be very slow. This is slow. Okay. It will not work very fastly because of huge number of features. Because of low polynomial degree, the model cannot work on the complex data set. These are the two drawbacks of the polynomial features. Okay. So now these two drawbacks are overcome by the help of polynomial kernel. So one is there are two types of degrees are there. One is low polynomial degree and high polynomial degree. If there is a low polynomial degree, that will not work on the complex data set very well. And if it is a high polynomial degree, it works on in all the features, but the model goes to be very slow. So these things are working with the help of a polynomial kernel. Now, when using the support vector machines, we can apply almost mathematical technique is called a kernel trick. So the kernel trick is overcome the drawbacks of the polynomial features. Okay. Now the kernel trick makes it possible to get the same result as if we added many polynomial features. Okay, even with very high degree polynomial features and without actually having to do adding them. So this is because of the kernel trick. Kernel trick is overcome whatever the drawbacks of the low polynomial degree as well as a high polynomial degree. So that is the importance of the kernel trick. Okay, so there is no combinative exploration of the number of features because you don't actually add any features. Okay, this is the advantage of the kernel trick. Okay, this trick is implemented by using the support vector class. So now you'll see an example here. The data set is contains two parts of data sets are there. Okay, two parts of class labels are there. What is a positive class? Simply it is called as a moon data set. It is called as a moon data set. It looks like a moon half moon data set. Okay, so it contains a positive class and it contains a negative class. Okay, negative class. So this is a one type of nonlinear data set. Our aim is how to classify these two into different classes. Okay, with the help of our model. Now here we cannot supply this with the help of linear classification. Okay, now we are going to apply technique called as a kernel trick. Therefore, kernel trick, we are going to classify the data into two parts. Okay, this is about the kernel trick. Now, in order to execute this one, we are going to use the model called as a support vector class classification. So that is going to be imported from the sklearn.svm. So in order to import this one, we are going to follow different steps sequentially. The first step is we are creating one object called as a polynomial poly underscore kernel underscore support vector machine underscore classification. Okay, that is equal to pipeline. So the first step is how to forward the thing is called as a scalar, that is a standard scalar. The standard scalar is equal to z equal to x minus mu by sigma. If you apply this concept to all the data, it may be x axis and y axis, all the data points are, all the features points are converted into same range of data. That means -2 to +2 range only. Okay, what are the features of the original data set? That is converted into -2 to +2 or -1 to +1 like that. Simply that is called as a standard scalar. That is, we are going to import from the standard scalar. Okay, we are implementing those things, standard scalar. So with the help of this one, we are converting the data into -2 to +2 range. Then we are going to apply our model. Our model is called as a support vector class classification. In this, we are going to provide the kernel equal to polynomial and degree equal to 3 and coefficient equal to 1 and c equal to 5. Already we discussed about the c equal to 5 is a soft matrix class classification technique that is going to be with the help of c value. Okay. Now here the very important technique is called as a kernel equal to polynomial. Okay. Now these two are sequentially added. Okay. That is pipeline. In the pipeline, the first step is a standard scalar and the next step is we are going to apply SVC or model support vector classification. In that we are providing the polynomial and degree equal to 3, coefficient equal to 1 and c equal to 5. Then we are going to train the model. So that is the model is our model polynomial kernel assume data classification. Okay, fit is for the training the data, x is nothing but features and y nothing but corresponding class labels. So this is about our model. Now here this code trains the assume classifier using the third degree polynomial kernel. So it is represented in the form of on this diagram. Okay, here the diagram contains degree equal to 3 and r equal to 1 and c equal to 5. So here the help of this one we are trying our model. So the degree here is 3. Okay, so it classifies the data into separately, two classes separately. Okay, that is a triangle class and square classes, or blue class and green classes separately. Okay. Now, on the right hand side of this figure, we are going to see the degree equal to 10. So here degree equal to, here the degree equal to 3 and here the degree equal to 10. So see this one, if you see the left side of the figure, some of the, it's not classified the blue point into blue colors. Okay, this is the drawback of this degree equal to 3. So here we are going to increase the degree of the degree equal to 10. Okay, instead of 3 to degree equal to 10. That means the model is exactly classified all the points into two classes. Okay. So this is because of the kernel trick and degree equal to, we are changing the values of degree. Okay. We are changing the values of the low value to the high value. Low value to the high value. Okay. This is called the kernel trick. Okay. Now, so here, if the model is overfitting, we might want to reduce the polynomial degree. Suppose the model is going to be overfitting, at that time we are going to reduce the polynomial degree. Okay, so if it is underfitting, we can increase the degree value. So there are two types of techniques are there. One is one is overfitting and underfitting. If it is overfitting, we are going to reduce the underfitting. Okay, underfitting. If it is a overfitting, then we are going to reduce the polynomial degree. If it is a underfitting, we have to increase the degree. Okay, simply this is how to follow in order to overcome the drawbacks of the overfitting and underfitting. So the hyperparameter, the coefficient of 0 is there. The coefficient of 0. It controls the how much the model is influenced by the high degree polynomial versus low degree polynomials. This is a very important parameter that is called a coefficient of 0. Now, a common approach to finding the right hyperparameter is we are going to use the grid search. Okay, it is often faster to first to do a very coarse degree search. Okay, then the final grid search around the best values you have found. Having a good sense of each hyperparameter actually can also help you settle in the right part of the your hyperparameter space. So this is about the polynomial kernel. In the next video, I'm going to discuss about the adding similarity features. Okay, thank you for watching our video. If you like the video, please subscribe. Thank you.